is. The fuck? We're running. Hey, player. There we go. Hey, Amazon Prime. So, yeah, I'm not sure how we're going to do this necessarily. We got to figure out. Next phase of this is we need to figure out evaporation, transpiration, and permeation each month for the water. So we're going to have the water flow. As it flows, we should be able to recalculate how much water is in the soil for plants to drink. So let's go through the monthly tile logic. Hey. Can you hear me okay? I do not hear Akala. Hey, Velarus Cats. Oh, sorry, I mean, Calandial. I'm trying to... No. Oh,
Hello?
oh, there we go.
Yeah, so...
So we have the usual chicken or egg situation, right? Because climate wants to know sort of where water is during a month, right? To know what evaporation is, blah blah blah. So and then vegetation needs to know what the new updates are to climate and water flow, right?
I don't think 1 month of a discrepancy between climate and plants will matter much. So I think we can just ignore it. And just work with whatever data is on highest at the moment.
Yeah, I mean, that's probably fine. But I guess so. I noticed like climate was coming after all of the others. So let's go to the world gen thing.
Climate is coming first.
Oh, hold on a second.
It's climate, hydrology, plants. It's right now.
Okay, and then the next climate tick picks up whatever changes occurred on the landscape from a hydrologic and vegetation perspective, right?
Yes. Yes.
Okay, so I guess so the question is, so climate happens first. Like, are monthly variables? They're not stored, right? You have to run a function to get them. So I guess it feels a little like it's, I don't want to say inefficient in the sense that, like, I don't want to have to run them for water flow and then for vegetation every single month, right?
If you have spare temporary variables, you can use them. But if we waste 3 megabytes of RAM on every okay, we're never gonna make a world bigger than 100.
Yeah, but I mean, there's other ways to economize here that don't necessarily involve plopping more variables on a tile. So,
Yeah,
for instance, consolidating. So, for instance, we could consolidate water flow and vegetation code, right? So
please don't do that.
No.
Keep the jobs separated, because if we start doing this, we'll have jobs that are thousands upon thousands of lines of code long, and we'll never be able to parallelize the music.
but it sounds like inferring. So when we need to infer humidity and rainfall and winds, etc., etc.
If we parallelize 10% of a job, because it's split into smaller chunks, it will by itself win more speed-ups than saving on recalculating deviations would.
Okay, so
Does that make sense?
yeah. So I guess it's just a matter of running all those functions to generate the monthly values. Then there's really no way around it.
Well, those functions aren't really. It's one array lookup and 3 additions.
Oh.
Those deviations are saved on climate cells, and a tile looks up its climate cell and then adds the deviation to its current temperature. And that's it.
Okay.
So it's not so. I have a suspicion we will slow the game much more if we start making consolidated jobs, which are thousands upon thousands lines of code long, because then no one will ever figure out how to spread them out on multiple cores.
Yeah.
If you notice climate, I try to split it into as small chunks as possible. So like climate is, I think, 7 different jobs right now.
Yeah, but I mean, there's no way. At the end of the day, I've thought about well, how in theory. So with the new water flow model, it actually helps because it takes a lot of the calculations away from vegetation. So when we revise vegetation, basically, rather than having to. There was a huge amount of not huge, but a huge chunk of vegetation was calculating how much water is available for a plant, like in this tile.
Nie widziałem się teraz. A tu już piszecie jakieś kioski.
They're speaking European.
My family was looking for tools in my room for some reason. Oh well. What were we talking about?
How a lot of with water flow, a lot of the water calculations that were on vegetation would then get shunted to the water flow.
Like those regarding available water in the soil?
Right. Because that's, I mean, basically, yeah. I'm just trying to figure out.
I think I added a variable for wetness in soil or something.
Yeah, so the only way, I think, the only variable that would need to be passed from the water flow phase would then just be the
wetness of soil.
Right, but I'm thinking too about like. So here's the thing, like so we calculate water flow for that month, but like how would it in theory be expressed to the player for that month if we're not sticking it somewhere? Like,
I'm confused. What do you mean? You can just change the map mode and say it's the current state of the world.
Right, but that variable has to exist like somewhere. Is it on water movement? Is it
tile water movement refers to water movement as it exists on a tile on a given day.
Okay. Alright. That makes sense then. Because I thought water movement was some long-term average.
See, can you screen share and show? Probably I open the stream. Can you open the game and like enter play mode for a single time? So we stand on the same node as to what we already have in game.
Yeah.
Because like, if you save the world, go to main menu, click on play, it already entered the game and unpause it and see how it changes.
Right. And okay, yeah.
And I think it would help if we were developing algorithms, both in play mode and both in game, and both in game and in origin.
Well, that's the thing, is I feel like we kind of just need to. Maybe it's just worth the sacrifice of having it be universal as opposed to, all right, here's our game. So just looping over what would normally just be in game time, right?
Yeah.
For the world gen phase.
So you want to write two algorithms for one origin and game?
Just one algorithm as opposed to two split, right?
Yeah, that's play one. That's how it works right now.
Yeah.
Game time reduces your current interval.
Yeah, and I think really, I'm thinking about writing some kind of subroutine that just will infer how much vegetation to start out with in a given place, right? And then just launch sort of, that'll be the baseline, and then we only really need maybe 50 years of vegetation growth looped over in world gen.
Yeah, sure, that works. Mm-hmm.
Yeah, and then that should get us close enough to where we want to be, so that we're not.
I think we do 100 years.
Yeah.
At least with current code, so that trees have time to catch
colonize.
Or now.
You can infer that anyway. There's a couple of tricky things to deal with, but okay, that should be fine. So I guess really at this point it's a matter of figuring out the whole evaporation and permeation of the soil thing.
I would do it this way. In the hydrology code, you would create a variable called evaporated water. and you won't save it to anything, but you will calculate it and write a log at the end. And then a few days down the line, when I actually need it, I will pick it up from the job. I will save somewhere, and I will use it myself.
Okay, so is that going to
Because I
need to be a
assume-
temp? Is that going to need to be a
assume-
temp variable? Is that just going to need to be one of the temp variables?
I'm not sure yet because depending on how it's coded, I could just write it directly to the climate risk, right?
Oh, that's true.
It's
As-
like, yeah.
Oh, yeah. So could you, in theory, so couldn't it just kind of work the way water bodies work, where you have this reservoir of water in one of the grid cells, and then just pass it immediately upward to that cell?
Yeah, I'm not sure yet because I don't want a scenario where we'll corner ourselves into a single-threaded application, and writing to a grid cell sounds like something that could possibly force us to a single thread. Because you could have two tires in a single cell writing at the same time.
Yeah. Well, I mean, it seems like you could cluster cells, though. Well, no, because it's... Yeah, you'd have to figure out how you want to
Never mind. Regardless. What I mean is that you could create a variable called evaporated water in your job, and you could just calculate it but not save it anywhere, if that makes sense. And then I would save it myself in some convenient way for the climate. And
Okay.
I figure out the best way to multi-thread it.
Okay, so I just create the variable sitting in scope, and leave it there, and then you figure out what you want to do with it.
Yeah.
Okay, alright, I understand.
Because I assume we don't need it for plants. You don't really care how much water evaporated in a single time, right?
No.
You just care what the result is on humidity.
I only care that it's not there for water flow and not there for plants.
Yeah. Because what you care about is humidity, and you get that from climate.
Yeah.
Okay. There is also an issue with snow and glaciers. Because right now your code is only run, your glacier code is only run on, when you call the job with a generation type called January, right?
Say again?
Your glacier code for glacial melt in water movement is only called for flow type January and July.
Yeah, so the only thing that matters is I need to be able to infer in a given month whether it's sort of where in the seasonal cycle it happens to sit, right?
So what I think we'll need to do, maybe not right now, it's like next week or maybe this week. I think we'll need to add a variable for snow, and we'll need to mend that snow, because right now your ice code doesn't work in game time because it uses flow type January.
Yeah.
And that only happens in Warrior.
Well, see, I'm wondering if there is some clever way to infer. Okay, so you could, so for instance, you can infer. Let's not infer anything yet. Let's say we're in the month of March, right? And where you sit in the hot-cold cycle depends on like which northern or southern hemisphere you're in, right? But you can look at the co-latitude of your tile and be able to say, okay, well actually this is where I'm sitting as far as when it's hot and when it's cold. So when I see that it's, well, actually let me think about this.
You could just look at January and July temperature, right? It's the same thing, but adjusted for other factors.
Right. But I'm wondering if you literally produce snow that you plop on the ground, whether that's even necessary.
Climate will tell you how much snow there is.
Yeah, because then it's agnostic to sort of whatever the temperature was 6 months ago. It only cares about the temperature now. And so if the temperature now is low, you build up snow. But if you have snow on the ground and the temperature is hot, then you just melt it.
Interestingly, snow will need to be factored into an operation because of sublimation.
But it gets tricky though with glaciers though, because now
I have a research paper on this very topic. I mean, on the topic of handling snow and such.
Well, it goes back to, but we have to. The thing with glaciers is we want to avoid. Let me think for a second. See, because the tricky part about glaciers, and the reason why sort of a snow model won't work for glaciers, is that
you're saying we need snow modeling optimization of glaciers.
Yeah, because we want to be able to account for the physics of glaciers. So snow, like ice accumulation up here, has a net influence on melt down here due to the pressure at the top. And so the question is, how, snow aside, how do we handle that? And I think that's...
The best way would be to make glaciers a water body, and then you would keep its size and the edge of it. And I think the fastest, perhaps not most numerically accurate way of handling this would be to calculate rainfall for the entire glacier and then distribute it uniformly on the edge.
Nah, I don't. That would be because you can see if you can look.
I'm saying it would be fast.
Oh, what's that?
I'm saying it will be fast.
Yeah, but that's not the issue. Of speed isn't the issue. The issue is you can see that where that water ends up is not at all uniform.
Well, yeah.
But I'm wondering if an alternative approach could be, because ice sheets, you can record on the ice sheet. So let's say we do make it a water body. Cool. Like the variable's already there, right? It already has a tile pointer or whatever for it being a glacier. So it doesn't take up any extra memory, right? And so you make a water body out of it, and then you have data on that water body that says, okay, you're in the northern hemisphere, therefore, this season is your hot season, this season is your cold season.
Has to be broken in certain latitudes. I can hardly sell in some doors.
I mean, sort of, but you get very few. So, like, you can still, in this situation where we have some ice sheets up high, like, it still has,
What about the equator?
Well, the equator, you'll never have ice sheets. Or you shouldn't, at least.
Well, you will. You will.
That's where you use the snow model instead.
But you will have ices on the equator. I've seen them with your model.
Yeah.
Because some mountains can be up to 10 kilometers high.
And
at 10 kilometers, any kind of rainfall will produce a shit ton of ice.
Yeah, well, I mean, in that case, do you what is your warm season? And if it's that high, it's almost
That's
like...
what I mean.
Oh, well, I mean, in that case, then you just have an exception. So in that case, glacial melt doesn't... It happens all the time, right? Because you have ice accumulating at the top, pushing ice down toward lower altitudes where then it melts, right?
Yeah. In that case, why do you need to look at your latitude instead of your current temperature?
Because you would need to know that it doesn't melt at a specific time, but it just melts all the time. See, so in theory, we could use this method. So here, you would expect...
I don't understand.
Huh?
If water flow is running every month, why aren't you looking at the temperature at a given month to calculate the melt from the glacier on a given month?
Well, that's what we would want to do. And so you would have more extreme melt at different times, right? But if you're in... Depending on your latitude, right? So you'd have extreme melt the higher the...
Why latitude instead of temperature? If you are on your given month, it's the glacier.
Well, because we can't actually change the amount of ice that actually exists there, because then we change the elevation.
Okay, so we are still assuming the glaciers are constant. Or not?
So,
What I'm saying is that if glaciers are constant as they are right now, what you can do instead of looking at latitude is on your given month, you can look at temperature and calculate it from there.
Okay, so we would basically so basically what we could do is we create we still need to be able to modulate how much water is being released from the glacier as a unit, right? As a discrete thing. I don't see any way really around that. And so you basically can say this is how much the glacier should be filling up extra. The temperature is low. The rainfall is high or whatever. The glacier needs to fill up this much, right? And then based on the temperature that comes later, then it needs to release this much, right? Whew, ouch.
So I think there is an issue with constant glaciers because...
An issue with what glaciers?
If you have excess ice on your glacier in winter, it's not gonna resize, right?
No, it won't.
Yeah. So, and similarly in summer, it won't rest. So you cannot really calculate it directly by melting away ice on the edge. If that makes sense.
Well, that's the fundamental problem, right? We can't. The thing is we. How do I say this? Like.
How long does your job to sort the elevation take? It's like how many times? 2 million times? It should be like a millisecond to sort.
To do what?
I mean, the reason why we don't want to change elevation, among other things, is that sorting the elevation list takes time, right?
I mean, that's one reason, but then it also has to do with lakes, right? Because then suddenly the characteristics of the lake change.
Yeah.
It's just...
What I'm saying is that sorting 1 million things should be a non-issue on a monthly basis.
Sorting is not really the issue. I mean, the issue in this case goes back to, do we want every single water body in the game to then have to reevaluate itself every time ice melts anywhere? And then we're back to the same problem of, okay, yay, we get to spend 2 more months fucking around with lakes, you know? So I think...
Well, but you are losing something either way.
Oh yeah, well, I mean, right now, I think we've kind of... Feels like we've settled on just, we're going to have to not change any ice elevation because it's just...
We are not changing anything as it is right now. I don't think it makes much sense to write a very complicated solution to glaciers for their melting and depositing of water. I think you need some very quick and hacky approximation.
Well, I mean, the original solution was quick and hacky, but couldn't be done monthly, right? It really comes down to how much can we...
Glacial melt, like for water flow.
Huh?
I'm talking about glacial melt for water.
Right, but there already was, like, the original... The one that was written for just 2 months, January and July, was quick and hacky, right? It wasn't perfect, but it got the job done. Now the problem is we're trying to sort of extrapolate it out for each month, right? And if we could achieve it... Yeah, and if we can just achieve that, like, I'd be perfectly happy for the time being, because it's fast, it's easy, we get to move on.
Then I think we're understanding.
Okay. So the question is, how do we do that quick and dirty extrapolation, right?
I think you would use...
oh, wait, hold on. Do we... Wait, but we already have, like, the January, July temperature readings.
July works, but you need to skew it towards spring, right?
Yeah. I'm wondering.
Tell me if you see hear any noise, just please. Is it a mess in this area?
Yeah, I can definitely hear some screeching in the background.
Oh, I'm sorry. Tell me if it becomes an issue. But anyway, I think what we want to do is we want to plug January and July rainfall into a function that will skew them towards spring. If that makes sense.
Oh, okay.
Because we don't want to release it in July. We want
Right.
to release it in like March.
Right. It's tricky though because when spring is for different tiles varies, and so we have to.
I think we can assume that it's roughly in March, right? On average, at least for the update 0.2.
Yeah.
For 0.3, we can figure out something for lakes, and we can do it protocol properly.
I wish there was just. God, I wish. There
Oh,
was
and by the way, spring will vary from different types. Okay, vary from temperatures on them. So maybe something along this lines.
I'm just trying to come up with like a neighbor agnostic way for a tile to be like, this is where I sit in the season. Like, it gets so much easier if we have some function that gives us like all right, time to start melting. Okay, and
Mm-hmm.
but that's.
I don't think such a thing exists because summer is an astronomical definition. It's an astronomical definition, and summer is always at the same time every time, right? So maybe something like this. If summer, I'm gonna write some code on this code. Just give me a second.
Oh man, I might have to mute you.
No, I'm sorry.
Yeah, I realize though we still have an issue, and that is the storage on a given tile that's going to be releasing that water from the stored ice.
What storage?
Huh?
What storage?
I'm trying to think. Like, no. Okay, so I think I know how to make it work. Like, basically, we wouldn't store anything. We would be inferring. We would basically treat it the moment of a tile in its season. We would infer where it is, and then sort of have a multiplier based on where it is to how much water is allowed to flow, right?
Right.
But the tricky part is knowing. So what I was doing previously was I was taking, like, for instance, July and August rainfall values and then applying them to how much was melted, right?
Maybe something like this. this is the same idea behind it as your quick and hacky approximation that you called it last time.
If summer temperature is greater than 0, right, then you want to melt shit. Current temperature is greater than 0, then if...
And also, it's also a condition for... There would need to be a condition for ice, like in your example.
But if month is greater than 2... See, this is where I'm a little confused, though, because...
Well, you would adjust it for hemisphere, that's an issue.
But month 2, like month 2 means a very different thing in the northern hemisphere than the southern hemisphere. So how?
Well, not an issue. You can adjusting this for the hemisphere is like one more if statement. I can fix it.
Okay, I see. So right, total rainfall, you're then just chopping it into... Okay. Yeah. Oh, let me check something on my Duke computer. I'll be right back. Okay.
Here is how it would be for both hemispheres.
Oh, right, yeah. Then you just check the inverse.
This one's work on the equator, but you don't care about the equator, I guess.
Would we want to ensure that, because it gets warm, so initially when the melt starts, it should be slower than sort of...
This would distribute each uniformly.
Right, we don't want it to distribute uniformly though necessarily. We want it to sort of speed up, start out slow and then speed up as it gets warmer and warmer until...
Okay.
What's weird though is... Like so glacial melt in these situations is not like snow melt, right? It should, because snow melt gets meltier and meltier and meltier until it's gone. But these glaciers will melt faster and faster and faster, and then slower and slower and slower until they then start accumulating instead of melting. Huh?
There is a function for that. You could take a sine to the third power or something.
Okay.
No, a square root of a sine.
Right.
And then you would have to curve fit it so it's fixed on amount. That's not an issue, I don't think.
You want to math that out for me? You're good at mathing.
I mean, I'm doing it right now.
Math faster. Are you mathing?
Yes.
Stop talking and math.
So we would want this rainfall to follow like a curve between 2 points.
Yes. Right. I'll be right back. Sorry. Yeah, it seems about right.
It's also not completely correct because you have to multiply it by a constant, so that it's actually preserving rate. If that makes sense.
Right.
So it would be
So actually, this should be a relatively easy revision to make it monthly. Let's see.
So this has area of 4.575.
Why they?
Okay, so you have to divide this by that number so that the area is 0. And this would be your factor on a given month. And then you multiply it by yearly rainfall. And yearly rainfall would be 6 times Jan to July rain.
Let me a calculator here. Let me do an example case. So X is just the month that you're on adjusting.
So it would be like this.
Right. Yeah.
Is that right? This is monthly. This is monthly. Is that correct?
Let me run a test case here. Square root sine. Okay.
Yeah, this is correct. So
Okay.
this would be your monthly event.
Okay, so let's.
January plus July times square root of a sine of a pi times x minus 2 over 6, where x is the month, assuming northern hemisphere.
All right, so let's assume that we're in April.
Sure.
1 second.
April would be.
By 2 times 3.14. Okay, yeah. So this effectively is just going to be a multiplier, right, to whatever the value of the water is. Okay, so times 6.
Well, the whole formula would be as I wrote it on the last slide.
So let's say we have a total. Let's say January and July's rainfall is 40 and 40.
Yeah, you add them up, you multiply it by 6, and then you multiply it by the factor I gave you. Because they are average over the 6-month period.
All right, so the melt. Let's do a few tests.
So you have to add them and multiply them by 6 to get the yearly rainfall, and then you multiply it by the factor to get the monthly rainfall. And the factor integrates to 1 between 2 and 8, so that you don't lose any rainfall on a yearly basis. That makes sense.
Yeah. Let me make a quick. Whoops.
We did it in South. We have a special class for this called test.cs.
Oh, do we?
Yes. If you click on Solution Explorer and search for test.cs. There's a special class which executes count when you start the game.
Oh, I just want to run it as a console, just like a little console thing.
Yeah, of course. It's straightforward. It's
Oh.
in the console. There's a function in tests called start. And if you log something in start, it will log in the console when you start the game. So you run quick energy tests on
Okay.
maps and stuff.
Okay, well, I was just thinking I'd run just like some STD out type thing.
And that, I'm not sure that will even work because you have solution of them.
Oh, yeah. I'll just do it by hand then. So in April, 493. That's odd. 480. I think there's might be something. Hold on. So yearly rainfall. Yearly rainfall is about 480. I think something somewhere along the line needs to be like divided by 12 or something.
Divided by 12? Multiplied.
Well, okay, so yearly rainfall is 480, and yet I'm coming up with 493 melt in April.
Yearly rainfall is what? What value is the equation?
It should just be 480, right? Because you have. So let's say, for instance, here, Jan rain is 40.
I don't think I can say this, can I?
Oh, you can?
Yeah. Okay, I can
Oh,
say
okay,
that.
you can now. Okay. So yearly rainfall.
Isn't 400 in that case.
What's that?
Yearly rainfall isn't 400 in that case. It's 40 plus 40 times 6.
Yeah.
Yeah.
Oh,
that's
which-
480, not 400. Do you get 480 or 400? Because I'm on low.
Oh, it's 480. Here, let me share screen.
Yeah, sorry, I thought it was 0.
No. Here.
That's not what the formula gave me on April.
Hold on. Let me make sure.
For me on April it's 97.6.
1 second. Let me check again.
Like this.
Right.
Maybe you forgot about the division at the end?
I think I did, yes.
Division at the end is because the equation of the square root integrates to 4.5.7 over the period of the entire year. So you have to divide it so the area below the plot of that function is 1, so we can use it as a multiplier on the yearly sum, if that makes sense. I'm not sure how to explain maths to people.
Do any special considerations need to be made as far as expressing this equation in
This
C
was
sharp?
only for the northern latitude.
Okay.
For the southern latitude, I can modify it quickly, but give me a second.
Okay.
And this equation is like an approximation, similar to the one you made with worlds and glaciers. If that makes sense.
Mm-hmm.
So
Okay, right, I got the same result, which...
yeah.
Let me try,
So when should glacial match start for the southern hemisphere?
I mean, April seems like a good time for... What's that?
Because my comprehension of what summer and autumn is doesn't work for southern hemisphere.
Right.
I think it's like September? Or is it October?
I don't know. Hold on. One thing at a time. Okay, I'm just curious about what results I'm going to get as I modify the values.
Okay, so use this formula I gave you. But for the southern hemisphere, you need to pass a different x. That makes sense.
Yeah. So I'll basically just have to check to see what
Yeah, what latitude it is, and then you either pass a month or you pass month plus 5 modulo 12.
Okay.
It will just move the month back to range 2 and 6, so that it can be used directly in the formula. One second, it's not finished yet. Okay, maybe I can just code it. That should be easier. Because you still need to check for x in that range, right?
Yeah, I feel like let's do some napkin calculations here. It feels like we're gonna run out of water pretty quickly.
What do you mean on a quarter?
So yearly rainfall, if yearly rainfall is 480.
This will distribute water throughout a half of a year with a slowdown at the beginning and a speed up at the end.
Yeah, and then slow down near the end again.
Yeah.
But it feels like right here that, I mean, just looking at the numbers, we've already hit half of the water, more than half of the water, just in 2 months, exhausted. And I'm presuming May is going to be 150 or something to that effect. That's linear, but so it feels like we're gonna. It feels like we're generating more water than there was rainfall. Hold on.
We aren't. I can guarantee you that.
I know, but it sure does look like it.
Sorry?
Sure does look like it, though. Hold on.
It doesn't on my end.
I'm calculating each month, and
yeah, seems fine here.
yeah, That's what I thought. 158. 159 if you round. Now let's get July.
It's ridiculous to me that we are doing it because the equation, the coefficient on the right integrates to 1 on that period.
What's that?
The coefficient on the right integrates to 1 over the period of a year, so it cannot be wrong. Here are the months as I calculated them. Just 1 second. That's the results I got.
Should there only be 5 months of melt?
It would be 6, right?
Yeah.
Yeah, so this will give you very slightly less melt than what you want.
Yeah, because it should... Right, your 3 cold months are going to be October, November, December, January, February, March, so to speak.
This sums up to 446. So the reason why there is a small discrepancy is because the integral under the curve operates on infinitesimally small periods, and this calculation is on multi-periods. Does that make sense?
Mm-hmm.
Do you think that's sufficient?
Yeah, I mean, that would be fine. Trying to figure out why I'm getting bogus numbers.
Do you keep all the parentheses the same way as me?
I should, but I'm recalculating something right now.
Mm-hmm. Yeah, your numbers are, yeah. Mm-hmm. I see why you would be confused on the result, yeah.
Hello. Good. Yeah, everything's going pretty good. Everyone in Florida is still kind of not taking it very seriously. So, yeah, we're just staying inside. We're going to homeschool the kids and everything. Yeah. Yeah. But I mean, the good thing about no one taking it seriously is I don't have to go back to North Carolina anytime soon. So looks like work from home is gonna be, yeah, for another for another 5 months possibly. Yeah, John Presley's he's been kind of running metrics on everyone's productivity and everything, and everyone's on track with projects and all that. So it looks like, there's no rush. There's no productivity loss, so there's no rush to get everybody back into the innovation center. So. Yeah, well, I mean, like certain people like linemen and stuff like that obviously have to go back, but yeah. Nope, I think we're good. Gonna work. That's what weekends are for. What are you talking about? Yeah. Womp womp. Okay, alright, thanks. Okay, bye. Okay. It's funny. It's funny, I'm extolling the virtues of work from home with technically like my managers, and meanwhile I'm like not working. I'm doing like songs of the Aeons. But I'm gonna do Duke stuff over the weekend, so I'll catch back up with it. What matters is the work gets done. Alright, so what does this look like here? Okay, north, south, right. Okay, so it's gonna flip based on I guess a co-latitude check or something. If north, right?
Yeah.
So I guess determining north versus south is just checking whether co-latitude is positive or negative or something?
Whether the latitude is positive or negative.
Right. Oh yeah, sorry, what did I say? Co-latitude.
Latitude has to be greater than pi over 4. Sorry, pi over 2.
In inferring the month, it's either going to be... Yeah, okay. So it's either going to be one or the other. Right.
Yeah, because if you find that man doesn't start quickly enough, you could change it like 2.
Right. Okay, cool. This should work.
You can just... I would add it myself to the whole job, but I cannot because I'm in the middle of a huge rewrite of how our Lua generation works. I'm moving it to C# to Unity, so you can add variable without Lua.
Okay. Well, let's... Would you say this is finalized?
This equation?
What's that?
This equation or what?
Yeah. Mm-hmm.
I think it works.
Yeah.
I don't see any issue.
Looks solid to me.
The only issue is that it very slightly decreases the amount of rain by like 5%, I think.
Is that going to cause an issue, some negative feedback loop long term with like climate?
No, because by the time I couple everything, I will replace it with a proper calculation. That makes sense.
Okay.
Because the reason why it gives slightly lower values is It's because of how integration works. Yeah, let's not talk about it right now.
So, real quick, when we go back to okay, I see. So when we go ahead and calculate seasonal water flow, right, we'll only be assigning. Okay, so we can then assign the water flow specifically to the variables when we're at that specific moment, but flow type. Oh, okay. So when flow type is current, right, then we have water movement.
Well, I think you should only look at flow type current because it's the one that is used for plants and it's the one that is used in the game loop.
Sure. I mean, these are only really pragmatically for the user, right?
Yeah.
For eye candy, right?
Mm-hmm.
Okay.
I think you had a place where you were adding page helmet, like all the way up. There was some condition on ice. And you had a case for January and July, but you need to have a case for current.
Right. So really, all we're really need to do is swap it out here and then right here.
Yeah, I think you will just add a new case, right? Because you still want this for January and July.
Yeah, well, but we shouldn't. If no ice involved, release water in all seasons. Yeah, we don't. This is all gonna have to die. Well,
sure?
Yeah. I mean, this is no good because it's dumping tons and tons of water. We want the specific amount of water it's going to be moving for that specific monthly calculation. And here it's just a giant dump in the warm season.
The origin is... Okay, no. 1 second. This is if there's no ice.
Say again?
This evaluation part is if it's only executed if there is no ice, because it's in the else statement.
Still don't really know what you're trying to say.
You have an if statement for ice, and line 90, which you're looking at on the stream, is already a case where there is no ice. So it's already not a glacier.
Oh, right. Yeah.
Yeah, that's what I meant.
Yeah, okay. Yeah, the ice check is up here, and then if there's no ice involved, then it's else or whatever.
Yeah. Then.
Right, and then it's just as it is. I still think this basically keep the ice check, kill this, figure out what month.
But if you kill this, once you kill the eye candy?
No, because well.
If you kill the eye candy, won't go.
So it depends. What do we want? It's a question of what do we want to show on the variable of January, July water flow? Do we want to show all of the water flow that happened between January and June for January, and then all of the water flow between July and December for July? Or are we trying to say, hey, the rainfall at this moment on this month is this much?
Okay. Well, it's up to you. I don't really care either way.
Yeah, I don't really know, to be honest. Wait, what is the climate? But the climate stuff gives you... So the climate variable of humidity July is giving us that specific snapshot. Right?
It's giving you long-term averages.
Oh, right, long-term average. Shit.
Yeah, you have get humidity for you have a function called for a given month.
Right.
So you can get it.
So I don't really know what to do then.
Sorry?
Yeah, so I don't really know what to do with the waterfall though then, because here, for instance, it's not operating off of the same melt baseline, right? We want... This isn't going to give us an accurate perspective of how the melt is actually occurring.
Okay.
So I guess... And we don't want to have to run rainfall an extra or to run the whole water flow thing an extra time just to, yeah.
Okay. I don't particularly see the issue though. I'm sorry.
You don't see the issue?
No, it's like, yeah, I'm not sure what you mean.
Thinking.
Mm-hmm.
So the issue is this, right? So the problem is half of winter is so we have like 2 seasons, so to speak, in the sense that we have January and July. We have January to July and then July to December. Half of winter is in both of those. Right.
No, that's not how I imagine it. I imagine it being more like September to March and then April to August.
Okay, so that's how you...
And then being summer and winter, not like half of year.
Okay, yeah, then that's fine then. Right, so January represents being in the is the median month of that season, is what you're saying?
Yeah.
Yeah, if that's the case, it's fine. Then we can theoretically keep this thing here and to sort of yeah, that would work.
I could rename it in the UI to like summer and winter, so that people don't get confused or something.
That would be a good idea, actually.
I originally named them January because technically it's not winter; it's only winter in the northern hemisphere.
Let's see. So yeah, so here's the thing. So do we just have this run is like an yeah, I guess that's fine.
Okay.
Let me think this through a little bit. Alright, so I gotta figure out. takes long-term average, goes ahead and flows. Current is just going to be the monthly rainfall. Alright, I guess it should be fine, yeah. But we have to... Okay. What the hell is it? Oh, I know what I was doing.
You need a case for flow type cap.
Yeah.
And then you presumably want to use my formula to calculate it. So
Why does month of first melt need to be a constant?
it doesn't. I just made it a constant because because presumably basically you want there is this general direction in my way of coding where I make everything a constant unless I know I will have to modify it. Because like if it's not a constant, there is a chance it is a constant, and you'll change it during execution of the code and mess things up.
Where the heck is... What's the variable name for latitude?
There is nothing, there's colatitude. Colatitude.
Yeah.
Colatitude. Yeah. And then there is a utility in a class called math. Not like this. This is the whole planet. Latitude isn't between -π/2 and π/2. You need to convert it to latitudes. There is a class called math utility, which contains a function colat to lat. And you'll need to use that if you want to use the conversion. Math utility, not math. Math is like a thing in Unity. Math utility is without the dot.
Without the dot? Because I wasn't getting any help from...
I think it's uppercase. Like this.
Oh, okay. There we go.
How do you keep pressing the dots? Yeah, math utility. See? And there should be a function called colat to lat in that.
There we go.
That's a class, not a function. Yeah, colat to lat. And that will convert colatitude to latitudes, which means you can compare it with 1 with 0 to figure out the hemisphere.
Do we have any... We'll just decide. There we go.
Yes.
If you happen to be 0, we're just going to lump you into the northern hemisphere. Okay. Relulo, that is correct, by the way, working on the glacial melt stuff. We're trying to make everything monthly so that you have different monthly rainfall, different monthly water flow, different monthly glacial melt and stuff like that. And then we can, be able to infer a lot of interesting things. Okay. So... Oh. You need to declare month as a variable.
You want to declare a variable which wraps the month.
Yeah, declare month as a variable.
I guess. I named it X specifically so it's not confused with the month, because it's not month. It's month adjusted for seasonic or seasons. Right?
If north. Okay. Where is month? Oh, month is just going to be whatever argument is passed for what the month literally is.
Yes, month is an input from the outside color.
Right.
And what you declare is the X, which is passed to the monthly melt coefficient.
Yeah. All right, we'll go with X. But month, was that literally the name of what we? Yes, we did. Okay. I didn't know that was an actual variable. Okay. Let's simplify things. Okay.
That is correct, yeah.
So if x is greater than or equal to month, now month of first melt.
Yeah. Basically, this way you'll be able to choose more easily on which month melting starts.
Right.
Like if we decide that March is too late or too early, it won't be difficult to change, right? And this is basically ending 6 months later. I think glacial melt is called EMP float 1 here. Like you add food or something.
Let me
I think you just add to temporary float 1. I think we need to add to it.
hold on, I'm thinking. No, we don't. Well, oh yeah, we do. No, you're right. We just have to. We just have to. We have to not add rainfall because that's.
You do have to add it because it's the current water on a tile.
See, but here's the problem. No, because then we'll be double dipping if we add that month's rainfall. Because we know that like if the total rain.
You're not adding this month's rainfall.
Yeah, but that's what I'm saying. We shouldn't. Like this.
Okay, sorry.
Yeah, I'm saying this is everything we need technically.
Okay, I understand. Sorry, I thought you were saying you're adding this somewhere.
No.
Mm-hmm.
I'm assuming just math.
Technically, ignore droughts, but I think we can ignore them on glaciers, right? Because presumably they happen more rarely to begin with.
Exactly. The glacier itself acts as a stabilization mechanism, I guess.
Yeah. And it's so gigantic usually.
Yeah. And in theory, like you would need like really long-term trends, to really completely exhaust a glacier. So it's like.
And we have them with melancholic cycles. The ozone is math.pi. No, math.pi.
Oh really? Oh, there's such a thing. I didn't know that.
Yes. Yeah.
Okay, now it's still pissed off. What are you pissed off about? Some kind of casting issue?
There is no semicolon at the end. I think it's a semicolon at the end, maybe.
Here, let me look around.
Maybe not.
It's something about.
You add an F at the end of the 4.57 something.
So it's a cat. Okay, so it's anything with a decimal needs. Yeah, there we go.
If you don't have an F, it's double. Yeah.
Then it's like you're trying to. Yeah. Okay. Mm-hmm. So that should just add it and then be picked up by whatever the seasonal flow is. So I guess the way we just test this is just generate the world and then run it in game time?
Yes, I think that's the easiest way to check it.
Alright. Oops. Let's kill Unity here. I'm gonna have to do some Duke stuff in a second. Let's just test this out, see how it works. Oh god. Ah! That noise, the racket. Sounds like someone's playing on the highest note of a harmonica in your house constantly.
Yes, I'm muting myself. Let's take another second.
Ice melts, water comes out, no one can explain that. Both in real life and in game, how far does the impact of glacier reach? Can lakes of the tropics be originally fed by glaciers and disappear if the lake... Yes, in theory, Roalo, if the river was long enough, or if the mountain was high enough for there to be glaciers atop it and coming down it, then in theory, I mean, that could be... Uh-oh. Oh, well, okay. Let's try this again. Yeah, but that's, I mean, those are cool edge effects, right? Or edge cases, Rololo, where you can imagine, so imagine, for instance, you had a massive, like a massive ice cap, right, at the top of the world that melts and drains all the way down into like a desert, right, and creates a giant freshwater lake in the middle of a desert or something like that would theoretically be possible and exotic, doesn't, exist on Earth that I know of, but I mean, it's funny because like the Indus River civilizations are technically beneficiaries of that kind of effect, aka glacial melt off of the Himalayas. Right, if we want to pop over there real quick while things are generating. Right. You have that effect where you have considerable amounts of accumulated ice melting in the warm season and then effectively nourishing one of the biggest floodplains in the world. Which is why there's so much conflict in Kashmir, right? Fighting over those headwaters.
So, if you save the world with brother.
Yeah.
And then we'll see how fast or how slow the game. Oh, we don't have a save folder.
Whoops. Oh yeah, I dumped it straight into documents. Whoops. Okay.
At least the game is not enough to not crash. If that happens.
Theoretically, I can still load the game off of just like
yeah. You can just quit the main menu from you don't have to close it. Oh, never mind. You could have clicked on quit in the bottom right. You want to click on play, not on load, because load will load the word in the word explorer.
Oh right, then we'll just be back to square one. Right. Right.
Yeah, I kept them separate because I imagine there will be people that want to
world edit and stuff like that.
Because some people are very weird. Myself included.
Yeah, it's important to mention, like Rololo, when it comes to dams, most of the time the course of the river is not modified. I mean, you could, in theory, sort of like decide to try to, for a period of time, starve someone of their water for a season by letting the water accumulate for a while behind the dam. But, yeah, most of the time, based on the shape of the terrain, usually water, it would be really hard to redirect the water completely. But it is possible, in theory. But play is unimplemented. Never actually even, yeah, okay. Well, I should say that's unimplemented, by the way. Add Unity to your taskbar. Doink. Boink. Hey, Cal. Okay, so months are passing.
Oh, you know that. Okay. If you change the map mode to the current water movement, which which is called waterflow, I think. Okay.
Is there?
We should increase speed to like 5 because the default speed is seconds per day.
Question though. The map mode that you're currently on isn't automatically updated when months pass.
It is though.
It is.
Yeah, we haven't passed a single month.
Right.
Can
Oh.
we increase the speed to 5?
Right.
The arrows to Well, we just write waterflow on the picture. No, but it's because it's in winter.
Something's off. Oh wait.
What happened?
I don't know. Yeah, something's off with water flow. Let's see. I'll let it go back around and then.
Did they mess up the conditionals in the
Yeah,
game?
I'm sure it's something stupid. Hold on a second. Oh no, why can't I see any debug? Any reason why I can't see debug values?
Oh, I understand.
Oh god, I can't make them go away, they're just everywhere. What do I?
Sorry, it's +1, not -1.
Abort.
I think one sign. I understand why it's wrong.
Understand why water flow is wrong or why there's no debug?
Basically, I missed one minus, and a plus became a minus in a place where it shouldn't.
Okay.
So after a month of first smell,
Yeah.
it should be +1, not -1.
Yeah, I just noticed that actually, because it's gonna basically tip us into negative values.
Yeah.
Yeah.
And then it becomes undefined because you cannot square root from
Right,
from
that
the-
makes perfect
and the
sense.
total.
Okay. Why are there no debug values, by the way?
You got value of what?
Oh, I mean the debug window. Sorry.
I haven't linked the mouse interactions to event in UI in game.
Oh, okay. That would be super helpful if we can.
Yeah, I need to do that. It's in play. You can still kind of log it if you're looking to Azure.
Oops. Okay, play. Alright, something's still wrong. So
Yes.
Yeah, it seems like I can't verify this because I can't click to see what the values are, but it's definitely you'll see it's what it's doing is dumping it's dumping the amount of water that should flow into the tile, I think, but then just failing to move, I guess. Let me see. Which is odd.
That would be quite odd because I think it just treats that water as normal water flow.
It should, right, because all of the other water flow stuff seems to be working, I think. Let me verify. So let's see if we have a shift in the monsoon region. It appears to be. Yeah. I think. Yeah. Okay, so we're definitely seeing a seasonal shift. So why? Oh, I think I know. Oh, I know. I think, maybe, possibly.
Can I tell you a quick way to verify the variable?
Sure.
So there is a thing called demand debug in the code base inside a file called debug buttons. Could you find it in Visual Studio?
Sure. Where did you say it was again?
In a file called debug buttons in Visual Studio.
Oh. Shit. Okay.
So you can do something like this. Just be that down.
Let's see.
Basically, you can log it yourself in console. If you add this line inside demand debug, because it's what it does is that it will call whatever is inside the function called demand debug when you click on your button.
Okay, and that way that way our debug modes aren't overlapping or whatever.
Yeah.
Tile from int world get world select the tile ID to string. Why is it complaining?
it's complaining because it's not including gem dot data, and it's missing parentheses because I was in a hurry.
Okay. Selected tile ID. Okay, so now it's pissed off here. What are you pissed off? Spell. Okay.
I think that should work.
Okay.
What it's gonna do is it's gonna find the word, it's gonna get the current second tile, then it's gonna cast it to a tile and get the string that we usually log in that UI on the left.
Okay.
Except it will log it in the console.
Alright, let me see.
So that's how way to circumvent the currently have with the UI then. If that makes sense.
Yeah. Okay. Loading. Where did it was Yeah, I don't see anything
It
yet.
should show up in the log, in the console.
Oh, as in, right.
Yeah. So you have to click on window and then console. Or just click on that. Yeah, that works too.
But where does it show? I see
You may
face.
have to expand it a little. Let me see. Can you scroll down and can you click on a tile, like on some tile?
Yep.
And then click on some tile and then click on demand debug. You need to click on demand debug to log it.
Yeah, I did. See, click.
Yeah, see,
Click.
it's here. Click on land. It's logged out. Click on land.
Land?
In the UI on the console, there's an entry called join between debug demand debug start and demand debug end. In the logs. That's it.
Oh, okay. Ah, I see. Right.
And if you click on land, there is the whole thing we had on the left.
Right, I see. And so that should give.
Exactly. But I can't fix the UI right now.
Yeah. Okay. That'll do for now, I guess.
You can expand it a little, so it's easy to read.
Sure. I'll sort that. Like I. Okay. So let's do this. Let's just run it. Now we're going to pause you. And we are going to hit Demi debug. We are going to click on you. We are going to open the logs. No! We are going to click here. We are going to... What the fuck? Ah, here we go. Climate cell. Temperature deviation, wind speed deviation. Cool latitude is land. Come on, water flow. Current water flow. Where is current water flow? Water movement 134. Yeah, okay. So yeah, it's dumping the water and then it's just not moving the water. So let's see. There's got to be something in the code that I forgot about that's just hanging things up. Seasonal water flow. So that's going to be a issue with the logic over here. Oh, I know. Maybe? No, temp. Okay. Where do we check for ice again? Let's check for ice. We don't check for ice, so why is it getting stuck? That's weird. Why is it getting stuck? If it is shunt water, the outlet, no, that's just nothing to do with it. If ice, then current, blah 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 blah, temp floats. What is the problem? Then this should end up making it over here. If is land, then we end up here. Do all the usual neighbor checks. Weird. There's very few places this could be having issues. So what is going on? See? And then this is your result, and then we add that to the result, to the neighboring tile. So what is the problem? Let me go over here. Temp bool is false. Now we go ahead. Yeah, I don't know. How unusual. There's no reason whatsoever that that we shouldn't have water flowing off the glaciers. I don't know. Because apparently it's picking up water movement. This is the only place. This is the only place we could be assigning water movement. As a variable. Here we have current. Yes. This would explain why. Plus equals. Yeah, okay, I meant to put plus and equals. So when it's getting to the next tile, it's wiping it out. Yeah. Question is, are we sufficiently avoiding adding other... Yeah, okay. This should be good. Okay. Right, if I can get this working, I'm going to go ahead and take a nice long walk. Do some more thinking about how we're going to deal with permeation. But that should actually not be too difficult. What's really cool is with the new permeation idea, we can actually simulate things like landslides very easily. Okay. Let's play. Moment of truth. What the fuck? Stop. Sons of bitches.
I just look at the stream. Fine.
Okay, what's going on? What the?
What happened?
It's saying the elevation is negative 2,141.
Oh. Are you writing elevation error?
No, elevation should definitely not be written anywhere for any reason. Oh wait.
You need to click on the email and refresh that. Yeah, it's very clunky.
Maybe it's just not giving me the right reading for elevation.
I mean, it's the same reading it gives for the thing on the left.
Here. Okay, maybe it's fine. Maybe I clicked the ocean. I don't know. That doesn't. That definitely.
I think it needs the ocean.
Yeah, this definitely does not explain though why water movement is like the raging Mississippi.
Well, I'm fairly confident that the equations have.
What? What is this?
What happened?
There's.
Wait, what is this? Is this so wet it's dry?
It sucked all the water out of everything below the glaciers? I don't know.
I think it's so wet it's dry.
Hold on, let's do this. What? Oh, no, now it's a river again.
Okay, so overflows only in certain months, I guess. Maybe it's because now glaciers aren't getting hit.
Maybe the water is draining off. Oh, I know what's happening. What's happening is the water is draining off the glaciers, but at some point we're getting a negative value because we blow past the float limit and it flips to negative. So there's something just screwy with the calculate. Oh, okay. Hold on. Let's see. There's probably an obvious reason for this. I got too excited about the fix. Yeah, okay, so I said plus equals.
Yeah, plus equals 6 times January times January.
Which should be legit.
Unless I messed up something with that month of first melt, this should work.
Here, let's do a sanity check real quick. Float.
Are we passing them all? At all?
Are we what?
Are we passing the month, at all, to the job?
We should be. Because
Are you sure?
it's working. I mean, the other seasonal water flow stuff works fine.
It doesn't use the month, does it?
Hold on, what are you talking about exactly?
I'm asking if we are passing the month to the job that we are declaring somewhere.
Okay, so it's here, right? And then if we go...
Okay, we are. Okay, that makes sense.
Yeah, otherwise you'd be flipping out that there's no variable for month there.
Yeah.
No, okay, so this value is calculating. I know it has to be it has to be calculating properly because if it wasn't calculating properly... Remember, so before we got water flowing, it dropped like 148 water movement in May, right? Which is what you would expect, right?
Yeah. I think so.
Oh, wait, let me see something. Ah, crap. I was thinking, let's go ahead and look at July and January water flow and see if it's screwy. If that's screwy too, we know it's a general algorithm issue as opposed to like a input issue.
Well,
Oops.
it was working before, so why would it break down?
I've seen this before though. I think.
Well,
I saw some time ago. I saw something screwy. I mean, but when I made the Reddit post yesterday, it was working fine. So, Oh yeah, it's also an issue in the other ones. Weird. What changed?
Huh. Okay.
Oh wait. Okay, I got another idea. Let's just generate the world from scratch and then see if it's also an issue.
Oh yeah, maybe it was broken because we had. Yeah, because we had that issue with the -1 before, right? So maybe it dropped the data and just stayed broken
Right.
all the way.
Yeah, it could have theoretically contaminated all the glacier tiles. Yeah, see, so it's intact now, so let's go ahead and save. I gotta fill out my time sheet. Still saving? Yes. Oops. How odd.
Is it still broken?
Now it just doesn't seem to be. Well, okay, wait, May. Oh, yeah, it's broken.
Yeah.
Weird. Why is it?
Oh, it's broken, isn't it?
It's even broken.
Oh, okay. So it updates at the end of the month, not during the month.
Why would that matter in this case?
I'm not sure. I'm just playing it when it updates.
So here's the strange thing. It's the same for every single. So like there should be nothing here for January. There should be nothing.
Are you updating anything? Wait, was that this way before you run the jobs?
Are we?
And maybe we are calling too much in the word search for word here in the solution.
You were cutting off like crazy there.
Could you search for this in the solution explorer? Yeah, and could you now search for seasonal water in this file? I think it's inside time from. It's inside game logic. Oh yeah, it's only current, right? Yeah.
Oh, so
this only happens on the fourth day. Found. Interesting. So we are not updating. We are not updating January and July, unless we have a bug in the code and we write it somewhere.
I gotta take care of a bunch of things. I'll try and get back later tonight. I'll commit what I have, If you want to look at it, you can. If not, I'll sort it out later.
Okay.
Here, let me.
Well, this is interesting though.
Yeah, I think we're moving in the right direction for sure. Okay.
And I got you to open the game as a game.
I know, I'm stuck in my ways. I get comfortable with doing things a certain way. But yeah, it's like when like users have opened the game, but one of the two lead developers hasn't.
Who cares about the gameplay anyway?
I'm pushing. Alright, I'll see you later.
See you later.